doing so much factoring like we did in the warm-up. We will be using the factoring, but we also will be using some graphs to solve these equations. Example, 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 practice. So 3 examples is our lesson for today. And then we have some practice. So each of you have a calculator, and it says solve by graphing. There we go. So we'll get to the calculator in just a second. Sorry, I kind of set that up poorly. But if we just had to graph this like what we worked on last chapter, I don't know why this is so glitchy. But if we just had to graph this like we worked on last chapter, what is the first thing that we would probably look to do? Find what? Find the vertex. Yep. We find the vertex by opposite of b over 2a. A is just 1, so our x-coordinate on the vertex is -1. How would we find our y? Yeah. Yeah, plug it in. Nice. Go ahead, plug it in. See what we get. Plug -1 in for x. Let's see. That would be +1, -2. You know we're going to be at -1. Somebody got an answer? What'd you get? -4? That's what I got too. -4. So our vertex is at -1, -4. -1, -2, 3, 4. Boom. Is this parabola facing up or down? Amari, is it facing up or down? Down? Why do you think it's facing down? You don't know? We know if our parabola is facing up or down based on what is with the x squared. If it's positive, then it's facing up. If it's negative, then it's facing down. So we have a positive. Remember that would be our a value. It's positive, so this graph would be facing up. Okay. Now it's kind of difficult to see what those x-intercepts would be just by hand drawing a graph. Okay. We can have an idea that maybe it's somewhere around here, like around negative. Let's see, that would be like -4-ish, maybe. And maybe this one's around +1 or 1.5 or +2. But just by drawing our graph, it's pretty difficult to see exactly where this would cross. Can we agree on that? Just by hand drawing a graph, it's pretty tough to see. So what we can look to do is to plug it into our calculator. So why don't you turn your calculator on, hit y equals. Hello. How's it going?
That's so bad on unit 5.
Yes.
Okay, thanks. That's
Yep.
all I needed to know.
Yep.
This is so bad.
The I had an in-person portion that I gave them.
Yeah.
And that was rough. They have a take-home portion, and I've seen a couple of them. They just emailed them to me, and it's rough. I'm not exactly sure why. I give it pretty straightforward, like not messing around with even story problems or volume or didn't mess around with that stuff. Here it is.
Plug it in, man.
Yeah.
Here's the formula.
Yep.
You use the exponent rule.
Right.
Yeah.
That you
Very
learned
factual. In Algebra 1. Yeah.
Yep.
Okay.
Yep.
So just look at it again.
Yep.
Yeah. So it just means squares, all there's cubes.
Right.
Same rules.
Right.
Okay. I just wanted to know. So.
No, I'm with you.
Whew. Yeah. I'm going to give a retake option. They're going to have to redo something and then take it to school. That's it. They will get this week. Done.
Gotcha. There you go.
I never do that, so I'll just give you
Not hitting where things are at.
Ha! Awful.
Yeah.
Thanks for letting me interrupt. Sorry about that.
You're all good. We needed a quick commercial break, right? Right. Every 5 minutes. We probably wouldn't do more of that. Do we throw it in our y equals? I haven't done it yet. X squared. Do we all know how to put that in our y equals? I guess that'd be a good place to start. Maybe? No? So, turn on your calculator. The y equals button is on the top left. So top left, hit y equals. You should get a screen that along the left side has y1, y2, y3, y4, y5, and a bunch of equal signs. Okay, in the top one, in your y1, if there's anything in it, you want to clear it out. So just hit clear if there's anything in any of those. Clear them all out. And then we want to type in x squared. X squared plus 2x minus 3. So plug in our equation there. And then hit enter. Yep. Now, let's think back to, we're going to want to look at our table, but just for a split second, let's think back to last trimester, maybe first try. When we had lines, right, or linear equations, we wanted to find the y-intercept, right? That is what we focused on, the y-intercept, right? With lines, we focused on finding the y-intercept a lot of times. Right, not a lot of times, right, equation. Every time, right, equation. Now, what was, when we found our y-intercept, right here, what was the x value? Always. What was the x value? Always, no matter what. It was always 0, right? If we looked at our table, or if we looked at, they gave us a table and a problem, we could find what our y-intercept was because x was always 0. Now, this time with these parabolas, we're focused on finding the x-intercept, right? We're focused on finding when this graph crosses this line. So, what would our y value have to be? It'd have to be 0. Yep. So the best way to figure out what this x-intercept would be to hit second table in the blue, our top right one. Second table, top right, and we can look at our table. If we look at our table, at what point does y equals 0? There's 2 of them. At what? 1 and negative 3. Yeah, so my graph was a little bit off. It should have came a little bit steeper here. But at x equals 1 and x equals negative 3, our graph crosses the x-axis, and that would solve this equation. And we can double check it just to make sure if you don't believe me. If we were to factor this, like what we just did in the warm-up, we need a negative 3 on the end, plus 2 in the middle. So we would go plus 3 minus 1, right? That would give me a negative 3 on the end and a positive 2 in the middle. So x would equal negative 3 and positive 1, right? The same exact thing as when we graphed it. Isn't that cool? We previewed it like 2 months ago saying, hey, we're going to solve these right here, and we're just going to solve it for fun and not tell you what it actually means. And now we're telling you what it actually means. You guys have probably been wondering for like 3 months, why are we solving these? Why are we solving these? What do those zeros mean? What? That's why. Because now we can find where our graph crosses the x-axis. By graphing or by solving. Pretty cool. That's what I was thinking. Okay, we've got 2 more examples, and they won't take as long. It'll go a little bit quicker. Solve this by graphing. What's the first thing that we need to do? Can we just throw this in our graph right now? No, why not? Because we did it on the last one. Lily, why not? It's not equal to 0. Good. We need to first set this equal to 0. So let's subtract 16. Oh, add 16 to each side. X squared minus 8 x plus 16 equals 0. Wow, this is like the glitchiest it's probably almost ever been. Now that we have it set equal to 0, now let's throw it in our graph. So hit your y equals again. Hit y equals. Clear the last one out. And type in x squared minus 8x plus 16. And let's look at the graph first. So hit graph first before we look at our table. Who can, after they get their graph, become the teacher for a second and just sketch a graph on the iPad for them? Someone who didn't do a problem earlier. So that takes Lerp, Skylar, Maya, and Joe off the table. Come on.
It's right there. I mean,
It's right there? Wait, let me see. Sweet! Throw that red one on there for us, Cat. You got it. You just can draw. Now you didn't clear out the old one, so hopefully you know which one's the old one and which one's the new one. No, it would be your graph. You got it. Right there. Sweet. Yeah, it's pretty bad. Sweet. Perfect. Thanks. So, this one's different than our last one, right? On our last one, the graph clearly crossed at 2 points. Okay? With this one, we call this a touch and go. Okay? The vertex is right at 4, 0, and it touches 4, 0, and it says see you later, and it keeps going. Alright? So if we have to solve, I mean the whole reason we're graphing these is to solve these equations. We would only have one answer when there's a touch and go. Last time we had 2, this time we have 1. In this case, our answer would just be x equals 4. Would be our only answer because it touches this x-axis at 4, 0. If we had one where it was a touch and go at like -3, then it would be at -3, 0, and -3 would be our answer. So whatever that x value is that vertex is at would be our solution. Now again, we can check this by factoring. We need x minus 4, x minus 4. So our only answer would be x equals 4 if we were to factor it out. So we can check it. Right, Lerp? We can check it. Yeah. So there's our first 2 situations where we have 2 answers, like up here, where we have 1 answer. And what do you think this last situation is going to be? How many answers do you think we're going to have? We went 2, and the last time we only had 1 answer. 0. 0. First thing we need to do is get this set equal to 0, like Lily said on the last one. Now, throw this in your graph. Throw it in your graph. Clear all the old ones out and throw this one in your graph. X squared plus 4x plus 5. Are you throwing this in your graph, Chad? Whoa. Somebody who hasn't drawn anything yet today.
already did.
What, Lily? Sweet. It's a little glitchy, but just do the best you can. So this one, it never, you can see it's up 1, so it never touches the x-axis. So it's not touch and go. Also, it doesn't, like our other one, our first one, it doesn't cross twice. So it never has anything to do with the x-axis. So this one would have no solutions. No solutions. If we wanted to find the vertex of the parabola, like these ones so far have been pretty obvious. If we wanted to find the vertex and we went to our table to try to find it, what would we be looking for on our table? Like how do we know that we found the vertex if we look at just our table? What should happen with the values around our vertex? Yeah. What?
Did you raise your hand?
Stretching. What should happen with the values around our vertex? What? I don't know. I think he would volunteer. Lerp likes to participate. Yeah. What is our vertex in this one? That's at -2, 1. So go to your table. Look at -2, 1. What's happening at the points around it? What do you notice? What pattern do you notice? Remember, we had second table to go to our table. This table's the top right. Our vertex is at -2, +1. What's happening around that value? Yeah? You got thoughts? They both they're going up, but like, is there any pattern? Well, you're on the right track. If we look at -3 and -1, and then if we look at -4 and 0, what do we notice about their y values on each side? They're the same. Yeah, the y values on each side mirror each other. Okay? So we're at, let's see, our vertex is at -2. This should not be a surprise. This is something we talked about many different times last chapter. At -2, we're at +1. 2, 5. Right? These values are mirrored. We have our vertex here in the middle, and then each y value is mirrored on each side. That's how we know where our vertex is. We can look at our graph and see where it's a minimum or maximum. We also can look at our table, which is a little bit of a review. Let's see. So here's an overview of what we talked about. Okay? We could have 2 solutions, 1 solution, or 0 solutions. It just depends on where that graph is. We have 2 solutions. If we have 2 x-intercepts, 1 solution. If we just have 1 x-intercept, like if our vertex is right on the x-axis, and then we have 0 solutions if our graph is totally above the x-axis. We would say no solutions. How are we feeling? Is this pretty tricky, or do we remember some of the stuff? Don't understand. What do you not understand? What, Lurk? You don't? You do? Okay, sweet. Joe, you have any questions?
Surprisingly, no.
All right.